Okay, so good morning again, everyone. I am Clarice Cortez, an applications engineer here at Maximum Solutions Corporation. And today I will be presenting to you our webinar, which is titled as Improving Structural Workflow with the AEC Collection. Okay, so I'm going to give you a short introduction first, and then we will be proceeding with the workflows for the following week. So we will be having the structural design and analysis workflow, steel design and detailing, computational design for structure, streamlined review and approval workflows. And at the end of my presentation, I will be flashing to your screen some of the resources that I think will be very useful for you in the future. And at the last part of our event, we will be answering some of your questions with the best of our ability. So if you have questions in mind, feel free to type them into our Q&A box or portion here at in Zoom, or you can also raise them at the end of our event. Okay, so with that being said, let's start. So envisioning a building design started out with a traditional manual drafting. And as we know, this is where we use the old paper and pen or tech pens to draw out our designs. This came with bulky rulers, T-squares, triangles, and the tubes that we used to carry our A3 sized papers. We would start off also with a pencil drawing first, and then finalize it with our pens. And then if we make a mistake there, we would start from scratch again. And then since there is no Control Z or the undo button that's available, this is very time consuming. So naturally, the AEC industry found ways to make the design process easier and more efficient. So this is when CAD or computer-aided design came in. So this was used by the AEC industry to design with ease and add a little bit of flexibility. And of course, my favorite, the undo command. We could make multiple sheets inside a single application also with the use of this. And of course, here at Autodesk, the primary application for this is AutoCAD. And this, but as we know, as our technology progresses, challenges and problems arise with it. That's why I listed here some of the structural business challenges that arise today. So first, we have increasing project complexity. So this creates an inaccurate estimates with lack of design information. And since we have more room to, our technology has already improved and we have more room to improve our projects, this made it more complex already. So next, design is disconnected from detailing. So here, detailers need a faster and more seamless way to collaborate with the design team. So especially during the detailing phase, data is often disconnected from the rest of the design team, causing a disconnected workflow. And the next, we have the hiring and retaining of the skilled workflows. So lack of skilled engineers, detailers, and also shop workers have an impact on the quality, even with global teams. So this puts greater pressure on fabricators to automate their lines to increase their output. And then lastly, lack of coordination on the job site creates wastes, which results to material waste and delays on the job sites, which means it causes inefficiencies also. So fabricators are being asked to use technology to provide greater insight into how they will deliver and install. Okay, so here you can see the structure, industry workflows, and personas. So we could start our process through the design phase up to the construction phase of our project. And as you can see, the red arrows represent the non-BIM broken workflows. Now, so here, designs, drawings, and models are thrown over the fence for someone else to handle, which means that data is not being shared and reused, causing challenges for the industry. So when we make a mistake at the middle, maybe at this part of your project, we would start or we would return our project up to from scratch. No, we don't have the flexibility to go back and forth with this one. While from the if you look at the double-ended arrows or the blue double-ended arrows, this represents the BIM-based integrated workflows. So this drives integrated workflows across the project life cycle. And you'll appreciate this more as I get into my presentation further. Okay, so with those challenges that arise today, here at Autodesk, we make tools to help people with design challenges every day to make anything. That's why the Autodesk vision is to help people imagine, design, and create a better world. And you also might be asking, what does BIM actually stand for, or what is BIM? So BIM, or Building Information Modeling, is an intelligent 3D model-based process wherein it equips the AEC professionals, or the architecture, engineering, and construction professionals, with the right insights and tools to more efficiently plan, design, construct, and manage buildings and infrastructure. So basically, BIM provides the necessary information about every component of your project, making it easier for you to gather data and to spread it also. Okay, so our portfolio for the BIM technology supports end-to-end workflows across the building disciplines. So we can start as early as the initial conceptualization design phase of your project and use this up to the end of or the completion of your project. Both conceptual design and analysis tools are also built right into our BIM authoring applications. And also, these solutions are interoperable, which means that you can move from one phase to the next to seamlessly collaborate throughout your project. Okay, so with that being said, let's move on to the different workflows that I will be presenting to you today. So let's start off with the structural design and analysis. Okay, so here you can use Autodesk Revit and Autodesk Robot Structural Analysis Professional. Okay, so let me just give you an idea of what Revit is. Revit is actually considered as the foundation of the structural workflow for BIM here at Autodesk, since you get to distribute or use your model in Revit and use that to the next phases of your project. Revit actually supports integrated and multidiscipline design, and with its single 3D parametric model that connects your structural design to the detailed model, you can make design changes easily. Here you can use the physical model for visualization, coordination, and also collaboration. And you can also use the associated analytical model for structural analysis and design with third-party applications like RSA, or Robot Structural Analysis Professional. Okay, so in this workflow, we can start by interpreting your architectural drawings within the Revit interface. And you can create the analytical design with this, or the analytical model with this. So a structure model can be created in Revit, and then you can send that in Robot. And then you can then perform the analysis within RSA. Here, internal forces can be calculated, and you can also run code checking with national and international codes. You can also verify and design steel, concrete, and timber elements with various, as I said, with various codes. No? After the analysis stage, you can send the information back to Revit for further detail. Okay, so here, Revit actually supports the building information modeling process for structural engineers by providing a physical model for documentation and coordination, and an associated analytical model to use for the structural analysis, as you can see in this video. Okay, so Revit can extend the BIM process to the analysis process through an advanced bidirectional link with the robot. So this can allow you to update your structure model in Revit after making changes in the robot model, or the other way around. So you are and your team can perform structural analysis seamlessly. So as you can see here, you can extract or make the models or your analytical models with their own shear and displacement diagrams also. Okay, so Robot Structural Analysis Professional, or RSA, provides structural engineers with the advanced structural analysis capabilities. So this includes for large and complex structures also. So we can analyze with the powerful finite element automeshing, nonlinear algorithms, and also a comprehensive library of country-specific codes. So RSA also features an advanced modeling and analysis capabilities for any type of structure. So here you can input or use load types like live loads, dead loads, wind loads, and seismic loads. And this can be applied to your structure as modal, member, and also surface loads. You can also perform a variety of analysis on the model here instead of creating separate analytical models. And as you saw here in this video, you have a selection of different steel elements here, like the angle bars or even the channel bars. Okay, so once you're done with your structural analysis, you can then send your model back to Revit for further phases of your project. Okay, let's talk about the concrete design and detailing in the AEC collection and our strategy for reinforced concrete. Okay, so our strategy for RC is centered around integrating the steel reinforcement detailing with the overall structural design and detailing process. So not only does this approach result in creating relevant and accurate documentation, it also drives end-to-end workflows in a fully connected and fully paperless way. So in addition to that, you can facilitate integrated structural design and analysis workflows. So Revit provides the necessary tools enabling detailers to model 3D concrete reinforcement, and also the creation of shop drawings and generate bending schedules in the advanced BIM environment with highly accurate 3D concrete detailing to quality 2D documentation. Okay, so flashed on your screen is the flow or the workflow for concrete design and detailing. So assuming that the structural analysis phase has already been done, the analysis results and the code checking results can now be imported into Autodesk Revit to give you an idea of the amount of steel and the sizes and other specifications of the steel reinforcement needed for your project. So when the results are already within the Revit interface, rebar definition can now begin. So this there are two available options for your process that you can use. So you have the option to use the US-based codes or the European-based codes. So the first step here is for the structural engineer to analyze the forces and reinforcement patterns. Then the engineer can now use the engineering schedules or place tags in 2D or 3D views that reference concrete elements and reinforcement patterns. And then the next step here, rebars now can be determined more directly from the analysis results while respecting the local or international codes. So the beauty of Revit is that it allows for bold approaches, enabling you to work with architects, MEP engineers, and the other extended project team. Okay, you can also perform rebar clash-free modeling. So you can perform this using, again, Autodesk Revit and also Autodesk Navisworks Manage and Autodesk BIM Collaborate. Okay, so Revit will allow you to design your reinforcement elements with clash prevention in mind in both pre-construction phase and site execution phases also. So the model you created in Revit can upload that model in the Autodesk Construction Cloud. And then you can use that collaboration module to do the rebar clash detection. Once all the clashes are already identified, you can now, those clashes can now be quickly reported to ensure that these clashes can now be resolved. So this serves as an easy way of communication with your team, no matter how far you are from each other. So now, after this has been done, your team members can now be notified with that clash, and they can make the necessary they can make the necessary actions to resolve those clashes. And you can now be notified also when that change has been done and how the issue was resolved, complete with the date also. Okay, so Revit is actually a BIM-centric solution for the reinforced concrete industry that better connects concrete design and detailing to fabrication. So Revit provides the necessary tools for detailings for modeling 3D concrete reinforcements. And you can also access or extract the shop drawings and create the shop drawings and bending schedules in the advanced BIM environment. So this combines the versatility of 2D documentation with a higher level of fidelity and accuracy of 3D modeling of reinforcement and concrete elements with minimal effort to produce both. So as you can see here in this video, you can easily make the necessary reinforcements no matter how complex your concrete shapes are. And in this part, you can easily edit out the dimensions, the concrete spacing, or concrete cover of your rebar sets. And you can also, when the concrete element is edited or you change the dimensions of that concrete element, your reinforcement will automatically react to that change. And you can also easily extract documentations from your model here. So in the later parts of this video, you can see that when you edit out something or edit out a dimension in your 3D model, that will automatically reflect in your documentation. And here you can easily label your reinforcements. So they won't have to, or you don't have to show some of the eyesores for your documentation. And that, as you can see here, you can easily add the bending schedules or the shop drawings in your documentation. Okay, so here, what I am showing you is the ability to export an advanced steel or a Revit model into Navisworks Manage. So all of the properties generated here will import as well. So Navisworks gives you the possibility to review your model for accuracy, such as calculate distances, as what was shown. You can also calculate areas, angles through various measuring and markup tools. Here, the Redline tools panels is being used, and this will enable you to mark up viewpoints and clash results with the Redline annotations. Okay, so here in this video, we can see the coordination of clashes for rebar design between Navisworks and Revit. So once the reinforced concrete model has been done within the Revit interface, a detailed coordination clash verification is performed within the Navisworks Manage interface. So this was made in order for you to avoid problems in the construction site. So as you can see here in this video, the red and the green rebars have clashed, and Navisworks has detected that. Moving on to steel design and detailing. Okay, so here, again, you can use Autodesk Revit and Robot for the early stages of your project. And as for documentation, you can use Autodesk Advanced Steel. So the beginning of this process is similar to as what you have seen in the previous workflows. So again, you start with Revit and then set that to Robot for your analysis. And then once that is done, you can now send the model back to Revit to start with the detailing design process. So this is where you will be able to start the specifications and the parameters of your steel members and their corresponding connections. And then after that, for documentation of the steel structure, again, you can use Advanced Steel to add more further details, extract the shop drawings and other CNC data straight out of your Revit model. Okay, again, so assuming that the analysis for your structure has been conducted, you can now explore the results and start the design of your structural elements. So with the use of Robot, you can run code checking on members with national and international codes. So as you can see here in this video, by selecting the member set or by assigning the member set here, you can choose what type of sections you will be using. So here, you can use an I-beam channels, angles, or even user specified or custom specified member. So you can also optimize your code checking. So you can base that from the weight or the maximum or minimum height of your members. And as you can see here, when we extract or when we get the report here, this will include the section parameters and also the internal forces and capacities of each member. And you can see that we can also have data from lateral buckling and lateral buckling capacities. Okay, so once the design changes has been done here, you can transfer the information back into Revit, and then the designer can review your changes and update the physical model accordingly. Okay, so here within the Revit interface, Revit actually has a variety of parametric steel connections that are modeled with a high level of detail. So this includes a built-in steel connection design-based engine or steel connection design engine based on US and European codes. So you can verify your connections in Revit and send that to your steel detailer for final detailing. Okay, so here is the process of extracting the code check report. So this actually includes references to highlight the chapters to which the verification belongs according to AEC standards. Okay, so here in this video, we could see the process of extracting an accurate bill of materials and quantity takeoff directly out of the engineer's Revit model. So this allows you for the verification of steel models in Revit before sending the model to the steel detailer for final detailing. So as you can see here in this video, you can select aspects of what you want to add to your schedule to fit your company's, your clients, or even your detailer's preferences. So you can sort out these parameters also. And by directly extracting the quantity takeoff from the Revit model, you'll get more accurate quantities, giving you less rework, less errors, and more confidence in your output. You can also do the same with your connection. And as you saw in this video, you can directly extract the bolt schedules from your model. Okay, so focusing more on advanced steel this time. So advanced steel is actually built on AutoCAD and based on our Polno. A lot of you are already using AutoCAD, which is good, which means that you can use advanced steel more directly now. Advanced Steel is actually a powerful structural detailing software that's easy to use and comprehensive. You can accelerate the detailing workflows using 3D modeling tools, giving you more improved accuracy and less time from design to fabrication. Advanced Steel also has a seamless bidirectional link or integration and model synchronization with Revit, just like Robot, which means that you can import your 3D design models from the structural engineer as a starting point for your detailing. So here, Advanced Steel just connects the structural design and detailing design for structural steel, which means that you can shorten your project timelines overall. Okay, so here, Steel Connections from Revit actually preset the shop or field status of bolts and welds, which means that when the connections are imported within the Advanced Steel interface, the assemblies are automatically created. All there's left to do is for the detailer to set the number settings and number the model. This will then be ready to produce the erection and shop drawings of your project. Okay. And also another quality of Advanced Steel is that it has a very powerful shop drawing engine, like as you can see in this video, which allows a large range of customization and automation features. So we can match your steel fabricator's preferences for showing things like dimensions, marks, title blocks, and also a bill of materials layout. Okay, so here when modifications in the 3D models are made, Advanced Steel will automatically detect the drawings that need to be updated. So you can automatically update the drawing with a revision index and update the revision table. So this streamlined approach by connecting structural design and detailing process can reduce the waste and inefficiencies in the shop and also in the site, helping you design and detail your structural components in less time and less rework. Okay, so moving on to computational design for structure. So I've mentioned earlier that currently structural projects are getting more complex and more demanding, this is often confronted with increasing complex architectural designs, which makes modeling structures and analysis and optimization very time consuming, and thus it lengthens the design process overall. So structural optimization is an iterative process, which means that engineers in many designers can now design many solutions to find the optimal one to propose to the architect. Okay, so an answer to speed up the process of computational design is Dynamo. So here you can automate your tasks and optimize your designs. You can also explore parametric conceptual designs and create faster designs of complex structure. So let's apply Dynamo first in the automated structural design workflow. So here you can input your parameters within Dynamo, and then retrieve the model data, define the model Dynamo geometry, and this allows you for a quick and more efficient model generation. Okay, so basically, Dynamo is a visual programming language that allows you to set the algorithm of a certain task. So as you can see here in the screen, basically you take all elements in forms of nodes and place them on the screen. And then after that, you can arrange them accordingly and connect them. And after that, you'll have your algorithm. So Dynamos allows you to select aspects of your architectural model that you'd like to focus on and convert them into schematic structural beams, columns, and also slabs. And once the selection process is complete, you can experiment with the beam or column placement before finally settling on an idea that can easily be converted to a structural model that will allow you to add further design detail in Revit. So as you can see here in this video, you can easily adjust the height, the number of arcs, and arc division for this model. Unlike doing it manually, you have to do to adjust your model one by one, which is very time consuming. Okay, so basically with Dynamo, you can now automate your processes, especially with repetitive tasks, and in Revit, and build complex structures with minimal effort. Moving on to automated structural analysis. So this provides for more design options. Okay, so here you can create the analytical model in Robot. So this includes the analytical nodes, lines, and surfaces. And then you can now set the attributes, which includes the section shapes and gamma angles and materials. And then next, you can set or define the boundary conditions. So this includes the supports and also the releases of your structure. Lastly, you can set the definition of your loads. So this here you can specify the load cases or how you would apply those loads. Will they be nodal, linear, and surface loads? And lastly, you can run the calculation from Dynamo, giving you results from the analysis from RSA. Okay, so Dynamo has already been integrated in the latest version of Robot, which is the 2022 version. So we can install the Dynamo extension in Robot through the desktop app. So Dynamo for Robot enables analysis of more design options and more complex structures. So based on geometry defined by Dynamo, you can use the Dynamo nodes to create analytical models. You can also apply section shapes and boundary conditions and create loads, as I've mentioned. And here, this results to structural engineers being more productive and have more time to study the design options faster and fluidly. So as you can see here, you can easily apply multiple loads within your structures with just a few clicks with the Dynamo defined algorithm here. So you can perform multiple analysis with just a single model within the robot interface. Okay. Oops. So moving on, let's talk about the automation of steel connections this time. So again, you can use Autodesk Revit and Autodesk Robot, but on top of that, to boost your workflow, you can add in Dynamo. So Dynamo nodes are created to model the steel connections for your project. So out of the box, scripts are already run or are already ready to be run in Dynamo Player. So this is noted for steel connections that read analysis results. So you can read analysis results from load cases, combinations, and envelopes. And this analysis results are used to drive automatic connection placement, giving you faster design iteration. Okay, so here we have the steel connection for Dynamo package. So this reads the structural analysis results better, either from Revit or the results manager, which are imported from other applications such as Robot. So this capability lets you filter out the steel connections by the structural analysis results. So this filtering follows a simple rule. So the user selected force or moment or type is read from the beam or column end that is part of a given node that is being analyzed. So you can now then compare this to a range of forces or values that is also user set. And if the value fits inside of that given range, the rule will continue placing the connection. So this functionality to drive steel connections by the structural analysis results tightens the integration between analysis and detailing phases, helping you make better design decisions when adding steel connections to the structural model. So as you can see here in this video, with just specifying some of the parameters needed, with just simple clicks, you can now place the steel connections that is capable or based from your structural analysis. Moving on to automated concrete detailing. So this supports various structural workflows in Dynamo and Revit. And some of the nodes or the nodes that is being used here are shared with example scripts to automate workflows. And 100+ nodes are actually available for use for this one. So again, you can input your parameters within Dynamo, retrieve model data, define the Dynamo geometry here, and this will result in the rebar, automatic rebar generation of your structures. Okay, so here, what I'm showing you are two short videos running next to each other. So the one on the lower right here shows the manual process of creation of the reinforcements around the window opening. So this video is actually sped up 15 times. The second video on your upper left shows the generation of rebars for several windows and also door openings simultaneously using a Dynamo script run via a Dynamo player. So the difference between these two videos, as you can see, is very clear, and the value added by automation is a lot. So in this example, we were able to speed up the concrete detailing process about 60 times. Okay, so moving on to streamlined review and approval workflows. So cloud-based collaboration tool tools are enabling design teams to work in new ways on BIM projects. By centralizing project data in the cloud, you can now accelerate design delivery by enabling teams in multiple offices, no matter how far away they are from each other, to concurrently work on shared models. So in addition to that, this technology makes it easier for structural firms to work fluidly on design build, design assist, and ITD projects. Okay, so Autodesk Docs is a cloud-based common data environment, which enables you to organize, distribute, and share files with a single document management platform. So with this, you can reduce errors and rework, save time with streamlined review and approval workflows, and improve your team alignment and project scheduling. So by using Autodesk Docs, you can upload your files here, just like in this earlier in this video. You can upload your files in the browser. So this will allow you and your team members to have access to your files and comment in their inputs. So you can create issues within this browser. So this will allow you to keep you and your team on the same page throughout your project. So you can actually highlight your comments for the project here with the markup tool. So you can emphasize and assign that to your project team members. So they will be notified that they have to resolve that issue. Okay, so we've seen a number of Autodesk's BIM tools and workflows for today, which are all part of a broader portfolio for structure. And as you've seen and heard, Autodesk has great breadth and depth of BIM solutions. And these tools are designed to work together fluidly to give you a seamlessly connected workflow. Another benefit of Autodesk's portfolio is the way we offer access to our tools. So the products you can see at the top inside of this box right here are all part of a single solution offering called the Architecture, Engineering, and Construction Collection, or as we call it, the AEC collection. So the AEC collection is a great way to access Autodesk's BIM portfolio. And finally, we have our cloud-based collaboration tools here. This will help you put your projects at the center of the design team, providing your team members with the access to the most up-to-date project data whenever they need it. Okay, so here are some of the resources that I've listed out for you. You can just take a screenshot if you want to save this one. So here you have the Autodesk AEC and feedback community. And I've also added in the link for the Dynamo package where you can search that steel connections for Dynamo package. Okay, so that's the end of my presentation.